Something to recall with the potentiometer is that we do have a bunch of different ranges that we can use since this is a variable resistor. In one situation, we can have up to 0 volts passing through the circuit, or if we turn the dial, we can have up to 5 volts passing through the circuit. Keep in mind that the voltages are converted to bytes. Our 0 volts are equal to 0 bytes, and our 5 volts is equal to 1023 bytes. But our delay, or our time, is proportional to the amount of bytes and voltage. 0 volts equals 0 bytes, which in turn are 0 milliseconds. Or we can go all the way up to 5 volts, which would be equivalent to 1023 milliseconds. And if we were to place our potentiometer dial at the middle point of the potentiometer, we would measure out 2.5 volts passing through the circuit, which would be converted to 500 bytes, and which would result in a 500 millisecond delay, or a half a second delay. At this point, our circuit is up and running, it's well connected, our code is uploaded. As we can see, we turn our knob and we adjust the blinking speed of our LED. Challenge number 1, changing the range. Try multiplying, dividing, or adding your sensor readings so that you can change the range of the delay in your code. For example, can you multiply sensor reading so that the delay goes from 0 to 2046 milliseconds instead of 0 to 1023 milliseconds? So in this situation, we're only going to adjust the code so that we can change the delay. We are working with the delay only, so let's look at lines 31 and 34. So let's try multiplying. So multiply times 5, and then multiply or divide by 2. So now let's upload the code, but before we do, let's actually check out the serial monitor. Let's always have this open from now on. Notice that in my serial monitor we see a value of 1023. Remember, that is bytes, because our LED is staying on for 5 whole seconds, and it stays off for our pop position, whatever reading we get for our pop position, which is 1023 divided by 2, which would be half a second. So it's staying on 5 times as normal, and it's staying off for half the initial amount of time. You can also try adding by putting a plus sign, or you can try subtracting, and you can also see how that affects the blinking speed. So try it out on your own. Now that we're able to change the code in our circuit, we're going to start changing it physically by adding more LEDs. So in challenge number 2, we are adding more LEDs, and we're also going to make the LEDs blink at a separate rate. So in this situation, we're going to need a whole new set of LEDs, resistors, another 2 jumper wires, and we're going to go ahead and connect these items right below and then change the code. I'm going to add my new LED to this location here, column A, rows 5 and 6. And then I'll connect the resistor here, just like this 330 ohm resistor. I'll have another black jumper wire going to my ground. It's going to go from here to there. And then finally, I'm going to add another wire on pin number 12, because remember, I need to send electricity to my LED. So remember, the long leg on the LED is positive and the short leg is negative. If you don't connect these correct, your LED won't turn on. So just flip it and then just make sure it's turning on. So positive is going to 6A and negative is going to 5A. Oh, one problem. I need to disconnect my circuit. So let's make sure we do that. Here's my 330 ohm resistor. I'm going to pin E6 and the other one's going to F6. Let's go ahead and add that black wire to J6 and connect that to our ground column that has been activated already. So this whole entire column is activated. All right, and remember, this little gap right here is not allowing any electricity to pass from this left side of the breadboard to the right side of the breadboard. Here's my green jumper wire, and I'm going to be connecting this leg over here. And actually, there's a problem. My short leg is my negative leg, so I need to flip this LED around. So once again, I just flipped my LED around because my short leg is a negative leg, so that's going to ground. Long leg will be going to the pins, and it's going to pin 12. And now that we connect, we notice that our green LED is not turning on because it hasn't been activated yet, so let's go ahead and activate that with code. Anywhere I see 13, I need to do the same thing but for pin 12. So here in this situation in line 20, I have pin 13 activated as an output. So now let's copy that and paste it below. So Control C, Control V, change that 13 to a 12 to make sure we have that pin identified. And now we're also going to go down here. We see pin 13 now on line 31. So I'm going to copy this and I'm going to paste that below. So line 31 is sending electricity to pin 13. So now we're going to send it to pin 12. and then we're going to stop sending the electricity to pin 12 by adding a digital write low. So what we're going to see right now is, so if you notice, our red and green LEDs are blinking now at the same time after uploading the code. So we can also adjust this. So let's say we want to have them blink at different rates and at different times. Let's go ahead and add a delay right after pin 13 and let's see what happens. And remember, if you ever feel like you mess up with this code, just go ahead and hold Control and click Z and you'll undo whatever you did. You can always go back to SparkFun and get the original code. LEDs are blinking at different times. Try out a new challenge by adding another LED and go ahead and change the code as well. Enjoy.